So now let us move on to the another problem related to thick cylinder. Okay. Find the thickness of the metal necessary for a cylinder shell of internal diameter 160 mm to withstand an internal pressure of 8 Newton per mm square. The maximum the maximum hoop stress in the section is not to exceed 35 Newton per mm square. Okay, so that the given data are, so they have cylindrical cell and internal diameter. So internal diameter small d is equal to 160 mm. Therefore, internal radius R1 is equal to 80 mm. So 160 divided by 2. Okay. So internal pressure they have mentioned. Internal fluid pressure P naught is equal to 8 Newton per mm square. Okay. So they said the maximum hoop stress, okay, should not exceed 35 Newton per mm square. So sigma x should not exceed 35 Newton per mm square. Okay. Now we have to calculate the values of remaining that is thickness. So solution part. First of all, we know the formula, that is Px is equal to B divided by x squared minus A, and the sigma x is equal to B divided by x squared plus A from the Lamus equation. Okay, now we know the boundary conditions. So boundary conditions. So RTX1 is equal to R1. RTX is equal to R1. That is 200 mm. Sorry, 80 mm. Then Px is equal to P naught. Okay. So here Px formula is equal to P divided by x squared, that is nothing but 80 squared minus A is equal to P naught, 8 Newton per mm square. So here this is equation number 1, this is equation number 2, and this is equation number 3. Okay. So next we all know that, okay, sigma x is equal to b by x squared plus a. Here we know the formula, that is sigma x value, we know that. So b by x squared. So here also at x is equal to r1, that is 80 mm. Then we have to go for sigma x is equal to sigma r1. Okay. So which is nothing but b divided by 80 squared plus a is equal to 35 Newton per mm square. So this is equation number 4. Okay. So from this, okay, now we are going to subtract from this equation to this equation. Okay. So deduct 3, equation 3 from equation 4, so that we can get, so deduct 4 plus 3. So if we are going to do this, so this will get cancelled and this becomes plus 2a, okay, 2a, and 35 minus 8 becomes 27, okay. So 2a is equal to 27, okay, or else a is equal to 27 divided by 2, then it becomes 13.5. So a is equal to 13.5. So this is the value. So if I'm going to substitute this, I can get the value of b, okay. So substitute a is equal to 13.5 in equation 3. In equation 3. So equation 3 implies. So b divided by 80 squared. B divided by 80 squared minus a 13.5 is equal to 8. So from here b is equal to, so 8 plus 13.5 multiplied with 80 squared. It becomes 1,37,600. 1,37,600 is the value of b. So substitute a is equal to 13.5 and b is equal to 1,37,600 in equation 1. So equation 1 is b divided by x squared minus a is equal to px, okay. So equation 1 is px is equal to b divided by x squared minus a, okay. So here b is equal to 1,37,600 divided by 80 squared minus a value is 13.5. 13.5. This is px, okay. So we all know that px is equal to 37,000 by 80 square minus 13.5. It becomes 8. So 8 Newton per mm square. Okay. So we all know that if x is equal to r2, then px is equal to 0. Okay. So we have to substitute this equation so that we can get the equation. Okay. So here instead of x, if I'm going to take r1, that is if x is equal to r2, then px is equal to 0. So px is equal to 0, so that we are going to substitute px is equal to uh, b divided by x square minus a, okay. So instead of x, we are going to substitute r2. So b is 1,37,600 divided by r2 squared minus 13.5 is equal to 0, okay. So with respect to the second boundary condition, therefore R2 is equal to, so if 13.5 goes to that side plus 13.5 and R2, so 1,37,600 divided by 13.5, and the root under this answer becomes 100.95. So R2 is equal to 100.96 mm. We can say 101 mm. Therefore, thickness of cylinder is equal to, T is equal to R2 minus R1. Okay, so this is R1 and here it is R2. So if I am going to deduct this, I can get the thickness directly. So R2 value is 101 minus R1 value is 80. So it becomes 21 mm is the answer. Thank you all.